This is the first time we're doing Couchbase 105. Thanks for joining. We're going to talk about across data center replication. We're going to do some. I'm going to do some demos of that, and we're going to talk about the Elasticsearch connector and Elasticsearch integration. So I will stop between the two subjects for questions. So let's get started. So the first thing to know is that we use the acronym XDCR all over the place. So if you're looking for docs and stuff, XDCR will be a useful term to search for. You know, it's cross data center replication. Although that implies that you actually have to have multiple data centers, but as you're going to see, that's not necessarily the case. You can actually do it within a data center for different use cases. And in the case of Elasticsearch, we use XDCR to integrate with Elasticsearch. So let's kind of talk about those use cases. So we have unidirectional and bidirectional replication, source of truth cluster, where you're doing all your CRUD operations, and then you're doing a unidirectional or single direction replication to another cluster. There are a number of use cases for this. Creating a backup cluster or a cluster for backups is one use case where you can actually run your, maintain the data across two different clusters and then run backups off the second one, especially if you have a very high demand on your primary cluster. Backing up when you have a lot of documents and a lot of CRUD operations happening can be, a competition for resources. So some people actually, opt to actually create a completely separate cluster to run backups off of. And then, creating a geographic cluster, meaning you have a single source of truth where you're doing all your CRUD operations, but then you also use XDCR to replicate to other geographically located clusters for consumption only. That's just the unidirectional case where you do consumption only. And you can also chain those across. So you have a data center in the West Coast, and then you have a data center in the East Coast, and you unidirectional to the East Coast, and then from the East Coast, you unidirectional to Europe, for instance, and you can do this sort of chain propagation. Some people actually use unidirectional to create development clusters where they can, work with actual data during development, but not affect the production cluster. So, that's also a use case that we find people actually do, for testing and development to work with actual data. And of course, integrating with Elasticsearch is also a unidirectional replication. And then there's also custom consumers. If you follow sort of the protocols of Elasticsearch, of Couchbase and what the XDCR protocol expects as replies on the other end, you can actually create your own custom consumers, which receive documents, and then you can do things with those documents, on the consumer side. With bidirectional replication, it's basically very similar, except that you're populating multiple clusters with data modified in each cluster. And we're going to talk about conflict resolution. Whenever you're updating data in two different places, there's the strong potential for conflicts, and we'll let you guys, or I'll explain our conflict resolution in its current state, and also let you know about any concerns that you might have in that sort of bidirectional replication and things to avoid. So what we do is an active replication. For those of you that attended Couchbase 101, we partition our data into 1024 partitions, and then if we also configure replicas for failover, there's for a single replica there's 1024 replicas. However, with XDCR replication, it is actually per partition and replicated directly. So it's from an active partition in the source cluster to an active partition in the destination cluster. So each partition has a separate append-only file, then the XDCR process reads off that file, queues up replications, and does active-to-active replication. XDCR is also configured per bucket. So the XDCR process is responsible for queuing documents for replication, transmitting those documents in batches, keeping track of checkpoints if the streams are disconnected, and then if there's a network outage, automatically handle reconnection attempts between the clusters. So that's what the XDCR process takes care of. So the XDCR uses port 8091 and 8092. So on the left-hand side, you're going to see sort of this inverted Couchbase node on the right side. Those are like a second cluster. So with it basically connects with port 8091 and gets the cluster map and configuration. I have a typo there. So the first thing it does is get the cluster map and configuration of the destination server. That way it knows where all the partitions are located, and then over HTTP it'll also perform the data replication on port 8092. So that's basically the two ports that XDCR uses. And in both cases it's HTTP. For security, you basically, our recommendation if you want to secure that channel, the HTTP channel, is create a VPN tunnel between the two clusters, and just do the XDCR through the VPN. So like I was saying, we're doing active to active. That means for each partition we're replicating directly over to the equivalent partition in the destination cluster. The cluster map in reality, so in this case we just have one node in each server, so all those partitions live on one server. And so that seems really simple, but in reality, each cluster could actually have a different map between the nodes and which partitions live on which node. So when you're creating a replication and it retrieves that configuration and cluster map, it looks a little bit more like this, because these partitions in the source cluster will have its own map of which node it lives on, and then the partitions on the destination cluster will have its own map for where the partitions live on. And of course, you can have different size clusters here, and different configurations. The only recommendation is to stick with the same platform. So if you're running off of Ubuntu on the one cluster, it's good to stick with Ubuntu on the destination as well. And particularly between OS X and other operating systems. OS X, because of the default file descriptor limits, without asking users to change their file descriptor limits, we decided to reduce the number of partitions to 64, just on the Mac install. You can change that. You have to dig through and change configuration to be able to do that. But this is important to understand, is that you don't want to use XDCR between OS X and other operating systems, because of that vbucket and partition is not the same count. And because we do active to active and partition to partition, that's where you'll have a problem between OS X and other OSs. So we generally recommend using the same platform in both clusters. Cluster sizes don't have to match because we have that fixed number. So back in Couchbase 101, people always ask, well, can I change the number of partitions? Well, this is one example why we wouldn't want to do that, because, and we don't actually need to, but in this case, what we have is, an uneven cluster size in terms of nodes, and that's actually fine with XDCR, because it's partition to partition. It doesn't really necessarily matter how many nodes are in the source or destination clusters. Now, it may matter in terms of the volume of CRUD operations that the cluster on the left can handle versus the cluster on the right can handle, in terms of being able to write all this data. If the left side exceeds it, XDCR will have a hard time keeping up. So in that case, it will matter, but it's not. It can be uneven clusters between the two in terms of the number of nodes, and they can be configured differently in terms of resources or sizes, vertical size, horizontal size. And so in this case, we have, like, on the left side, we're doing unidirectional replication, but there's going from 2 nodes to 4 nodes. on the right side. So they don't have to have, the same configurations on both sides. In chaining XDCR, in this case, what we have is like I said, the one source cluster, and all the writes are going there. And then, we have this unidirectional XDCR to a second cluster. That one also is configured with a unidirectional XDCR. I don't know where the 1.5 came from. I guess I didn't have enough coffee this morning. The unidirectional XDCR between the second cluster and the third, so you can kind of chain them across. And in our docs, we show this lovely, geo map of, bidirectional replication between two clusters, in central and west, and then those are, also being, the second one is being unidirectionally replicated to two different clusters. So that's sort of the example of chaining between multiple clusters. You can kind of chain across that replication. So let's kind of look at the architecture. If you've been following this, watching this series, these diagrams are pretty familiar. So in this case, we're doing storage ops, and of course they go into the RAM cache. Then they go into the replication and disk write queue. The replication queue is for intra-cluster nodes, for failover, for replica partitions. And it goes to disk write queue, it goes on disk, and then goes to the XDCR replication queue. And it also goes to indexers for secondary indexes and views in Couchbase 104. We talked about that. And then it goes from the XDCR replication queue out to the remote cluster, the target cluster. So let's look at that animation again. So storage ops go to RAM cache first, then they go into queues, they go on disk and to other nodes, then they go to XDCR replication queue and indexers, and they go to a remote cluster and also indexed on disk for if you have views defined. Now, it's not necessarily like that the indexers and replication queue happen exactly at the same time, even though the animation is there. Our indexers, remember, from Couchbase 104 run in batches, and XDCR also runs in batches, and those are not set to time. They're not timed together in any way. So just to make sure my animation doesn't confuse anybody. So XDCR, just like secondary indexes and views, are eventually consistent. And again, we have storage ops. RAM cache is time 1. Then we go to the queues. We get on disk. We could say that is time 2 when it's on disk. And then it goes to the indexers and replication queue, and gets transmitted to the other cluster, and that's time 3. And because of the inherent gap between time 1 and time 3, by definition, it is eventually consistent. So here's the bidirectional replication. What happens when you write to the same key in two different clusters? You actually have a conflict, because in each cluster you have to decide which one is the correct one. Which of these clusters should win in this case. And we actually have a very simplified form of conflict resolution. And we're going to talk through that again. We're going to talk through that right now. So our conflict resolution rules are completely automatic, and they're currently not customizable. It is not time-based or NTP or vector clock-based. It is based on two different rules. One is the revision number, which is the number of times a particular document has been updated. In each cluster maintains their own revision number count, and whichever cluster has the higher revision number, whichever cluster has basically updated that document the most, will be the winner and will replicate to the other cluster. If a document is changed in a cluster with a lower revision number, the document will not be put into the replication queue. It will actually check with the other cluster, and remember, this is only in bidirectional. It'll check with the other cluster, and based on the metadata of the revision ID, it'll determine whether or not it should be placed in the replication queue. So the revision number is the main determinant. Now, if it happens that there is a identical revision number in both clusters, meaning the count of the number of times that document has been updated is equal, then it basically is random. It'll take the metadata off of each, the CAS, the flags, and TTL, and whichever has a greater CAS will be taken. So basically that's random because CAS is random. So the revision number is really the number one rule for conflict resolution currently. We have talked about changing and making customizable conflict resolution, but I don't have sort of a product roadmap for that. So this is how it works. And so this is important to understand, especially in bidirectional replication, that I actually caution you to make sure you understand the rules of conflict resolution when you do bidirectional XDCR, because it may not have the behavior you expect. Maybe you expect that whichever has the newest timestamp. Of course, maintaining NTP time across multiple data centers and clusters is very difficult, and so we opted to avoid that particular problem. And whenever you avoid one problem, you pick another set of problems. So understand that if you're doing bidirectional, the conflict resolution is based on the revision count. So what I do recommend if you want to do bidirectional is actually there are use cases that work just fine in bidirectional, and basically each cluster is a source of truth. So what you have is you prefix your keys by data center. So in this case, I put a DC1 and DC2 in front of my keys, and in a lot of the libraries you can kind of add that, automate the addition of the prefix. I know in the Ruby SDK you can, but it's not a very difficult thing to add to your code to prefix with a sort of a data center ID. In that case, you're not updating the same document in both data centers. In one data center, you're creating documents that are prefixed by its data center prefix, and another data center, you're creating documents that is prefixed by its data center prefix, and because of that, there's no conflict. But what the advantage of this is that you actually have data from both clusters in each of the other clusters, so you can still get the data, you can still query the data, you can still index the data, etc., and you avoid sort of the conflict, resolution sort of simplicity. And so there is definitely a use case, or many use cases, for bidirectional replication, but with caution. So you need to make sure you understand the conflict resolution rules so that you don't see behavior that you didn't expect. So since this is Couchbase 105 and we've done sort of the full walkthrough of Couchbase at this point, in terms of our core features included in the product, I kind of wanted to take a minute to talk about sort of what the document life. So this is basically a list of operations and what happens if you have pretty much everything configured. So you do a storage operation. The first thing that happens is it's stored in RAM cached, and it's a consistent database, so it can be read by the get operation immediately afterwards. Then it's added to the disk write queue and replication queue. What happens next most likely will be pushed to a replica node's RAM cache before it gets to disk, but it could be simultaneous. And now it exists for failover. And if you do a failover, it exists after failover. Then it's persisted to the active partition disk. It's added to the XDCR replication queue. It's added, the indexers read it off disk and index it. It's pushed to the XDCR remote cluster RAM cache. So it can be queried from the view once it's been indexed. It can be read on the remote cluster get operation once it's been pushed. And then finally, since if the destination is actually an Elasticsearch cluster, Elasticsearch itself will index it, and then it can be queried in Elasticsearch. So basically what this is kind of outlining is sort of the life cycle of a document when you do a storage operation. You have everything configured. RAM cache first, then disk, push to replica node, then RAM cache then push to replica node, makes it to disk, then it's put into replication, it gets indexed for views, it goes to a remote cluster, and that remote cluster is Elasticsearch indexes it and can be queried. So this kind of gives a full outline of kind of what happens, with Couchbase if you've configured kind of everything. And that other animation where I showed sort of the arrows and diagrams of time 1, time 2, time 3 are also helpful in mentally understanding what's happening and in what order. So I thought that would be useful. So let's kind of do a demo real quick. And I have, I'm actually doing this from Mac to Mac, and XDCR from Mac to Mac is fine. So on the right-hand side is my a laptop configured with a bunch of data buckets. So I haven't I've made an XDCR bucket here. Right now I don't have let's see, I think I might have had it set up. I'm going to go ahead and delete the replication. And I'm going to create a new one. Let's see, let's make sure I have no items in here. Let's start over. I'm going to add data. Okay, I could have items in there already, but right now this is my local Couchbase, and over here on the right-hand side is my laptop Couchbase. And what I'm going to do is I'm going to set up XDCR. So this is how you set up. First, you kind of make what's called cluster references. So basically that's the location and username and password of a Couchbase server. So there I created a cluster reference. Now I want to create a replication, and on this cluster is my XDCR bucket, and on my MacBook Pro I'm going to do the same bucket. Oh, I might want to put the IP address of my MacBook Pro in here, 192.168.1.1 sec. I put the same address here, .121. I hope I did the right password. I think I did. Hold on. Oh, I did that just wrong. There we go. There we go. All right, and now I'm going to create a replication. Let's do XDCR to XDCR. All right, so it's starting up. And on the...
Just Dave, sorry, can
Yes,
you
sir?
zoom a little bit? Because it's quite small.
Okay.
Thanks.
Let me see if I can do it this way. That way I can kind of zoom in both. Is that better?
Yeah, thank you.
Okay, let me see if I can make sure I get all the graphs I want on there. Okay, so this is the laptop. So I just created this replication, right? So let's go to XDCR bucket and outbound. Let's see if I can get everything on there. Okay. All right, now I'm going to have this iTerm. I'm going to see if I make it skinny so that you don't actually need to see anything here except that I'm running a command. So I created some scripts that just create data. So this is the first one. I'm just going to create 4,000 random users. This is Ruby gem called Faker, so it's got a bunch of users in there. So on the right-hand side, you can kind of see here that it retrieves some ops here, 4,000 items. And then you also down here, you can see, this was the incoming XDCR operations. So in that little burst, we created 4,000 documents. So here and here, we've got 4,000 documents. And I'm actually going to go ahead and let's just add some more. Let's make it 8,000. So there I just did it again, and it replicated across to the other cluster. And then I have a hold on. I have a small script that basically takes it queries a view that has the list of users. I have a bunch of views in here on my local cluster, and it basically gets a full list of all these users, and then randomly will update with an updated at timestamp, adding to the JSON. So let's go ahead and run that. And just so you can see, I'm going to slow it down a little bit. Oops. Wow, it actually found so now I have 33 items. So the faker gem randomly selects names and stuff, but it actually um, had a collision there. That email address already existed. Ruby update.rb. So what this is doing is randomly selecting one of these 8,000 users and updating the timestamp. So on the left side, you can see kind of the ops per second. I slowed it down just a little bit so you could kind of see the scroll. And we've got a nice pace here. And then on the right-hand side, you can see that there's ops happening in the target cluster. But this is actually sort of the XDCR ops that are causing it, because there's nothing actually else is happening on this cluster, on my laptop cluster. So this is all being transferred sort of across, XDCR from the source bucket to the target bucket. And I'm going to go ahead and stop that. And I can also delete all those documents as well. So Ruby delete, and boom, all the items are now gone. So that's basically sort of a quick example of XDCR hooked up between my two Macs. So let's see if we can answer. Are there any questions, Franco, that I can answer at this point before I keep going?
Yes, thank you, Joseph. We have a few questions, and I want to encourage everyone, if you have any question on XDCR, this is the right moment to write them on the chat box, and then we will move forward to Elasticsearch. So a question from John. Would we be able to use XDCR to upgrade or reorganize or perform any other data platform manipulation?
Let me see. Let me think about that. Like, would be able to upgrade. Well, you can upgrade already through rolling upgrades of Couchbase servers. So I guess let me try and think if there's a case where you would use XDCR instead of the normal upgrade paths. I guess. I mean, you could, but there's already easier ways to upgrade your cluster just through rolling upgrades with Couchbase Online. You could kind of do rebalance upgrades. I guess technically you could use unidirectional XDCR as well for that. At some point, you'd have to stop operations on the source cluster and kind of move your pointers for your application servers to the target cluster. But I mean, I guess it is possible for sure. I mean, it's just maybe not the most straightforward of upgrades paths. But you can do manipulation, data manipulation. Well, one of the things, one use case is for analytics actually. Sometimes people size their clusters and they don't want to actually have indexing happen on their primary cluster. And so they use just XDCR. They don't use views or secondary indexes on their primary cluster because analytics in the use case that I'm talking about, it didn't need to be real time in any way. So what they were basically doing was using unidirectional XDCR to another cluster that was sized for indexing. So it had a lot more CPU, and it was configured with sort of a different disk array, just for indexing, and so that was one use case. So they did the kind of unidirectional, and there was another customer that actually had two data centers, and they were XDCR doing unidirectional XDCR to a third cluster, which was used for sort of billing. And there wasn't a high demand in terms of CRUD operations for the billing, but it did have a lot of indexing. So it took two data centers, and then you did unidirectional to a single one, and that was used for billing purposes. So I mean those are some of the creative ways you could do it. And I'll show you sort of a GitHub repo of what I actually did. Created a Ruby Sinatra receiver for XDCR where I could retrieve documents, and it was sort of just a sort of an experiment where I was receiving documents. They were friend documents, and I was taking those and creating a task queue to insert node relationships into Neo4j. So I still only was using one database primarily, which was Couchbase, for almost all my information. But then I would pick out just node relationships to be able to do traversals, which, in any non-graph database, it's quite difficult, whether it's relational or Couchbase. Any non-graph database is very difficult to do attributes associated to relationships. So I actually used the Couchbase Neo4j combo, and I had this Ruby Sinatra receiver for XDCR. So then I would automate the graph creation instead of dual writing to both databases. So that was kind of cool. Any other questions?
Yes. This is a little long question, but I'm trying to, I'm going to read it slowly. So a question from Dan. So you have a cluster, we have two clusters with a unidirectional replication across data center. And in one cluster, the primary cluster, you only have use as a key value store. Is it possible to define views only in the secondary cluster and use the primary as key value?
Yeah, exactly. And that is actually one of the use cases I was talking about. Yes, for sure. And that, actually, even in my local machine, that's the case. Well, actually, my target cluster, in his case, doesn't have any views defined for XDCR. And XDCR, like views don't get propagated over, only documents. So you would have to define views in each cluster. They're not automatically transferred over. Just for that very reason, for like the use cases where you may not want the views to be created or indexes created on the target cluster. In this case, I actually have it on my source cluster, but it could have just as easily been on the target cluster where I define some views. So I randomly generate a whole bunch of users. And so like I have this, I have this view here basically that's only indexed locally. Yes.
Perfect. Thank you.
Yep.
And one last question from Michael. So is XDCR an all or nothing approach? So can you define what you want to replicate to the other cluster?
Oh, sorry again. Say it again.
Yeah, if it's XDCR an all or nothing approach, so do you have to replicate every single document from the first cluster to the second, or can you decide which one?
Yeah. Well, it is bucket to bucket, but right now it is all documents within the bucket. Of course, that was like one of the early requests was to be able to filter, and some people came up with ideas of using like a view definition as a filter. But that isn't right now the current state, but has definitely been in discussion for some time. I don't know exactly when it will get into the product roadmap, but most certainly we're thinking about it and talking about it. So right now it is all documents, but it is by bucket, so you can kind of separate by bucket in some ways. Like, see, I have look how many buckets I have here. I'm only replicating the XDCR one. So yeah, that's basically how it is right now.
Thank you, Jasdeep. And then we have a couple of questions on the security roadmap for Couchbase and then XDCR. Again, for this, we need to kind of interface with our product management team, but I can tell you that we have a few security features coming up with the next releases. So this year, in 2014, you will see many more security features being released by Couchbase, so stay tuned for that. And my last reminder is, for those of you who are new to XDCR, First Data Center Replication in Couchbase, tomorrow we will have an intro webinar on XDCR and Couchbase at 10 a.m. Pacific. I just posted the link on the chat box for those of you who are interested. And with this, we can move to the Elasticsearch part of the presentation, and then we'll have more time for questions at the end.
All right. So here, I just put some data back in because I was like, why is there no data in my views? And I forgot that I had actually deleted them all. I deleted all the documents. So, in this case, I am indexing on one cluster, and then right now there's only like one per zip code. But I had grouped it by zip code and reduced it count, but looks like there's not too many with multiple. I guess I'd have to have more users, more fake users in here. The random was too good. So let's go back to presentation. It's actually quite simple because we use Elasticsearch. We use XDCR for Elasticsearch. So this part is actually simple and kind of brief because we integrate with Elasticsearch via XDCR. The reason we do this is actually so that Couchbase server and that cluster can be scaled independently of the Elasticsearch cluster, which they actually use a very similar strategy of sharding and distributing shards across servers. It's almost identical. It's not exactly the same, but almost. If you have very high search volume and search traffic, you can scale your Elasticsearch cluster, bigger. And if you don't have a lot of search as a part of your application, you can keep it smaller. And by decoupling the two, it makes it so that the configuration you need for Couchbase server in terms of CRUD operations and RAM and CPU, etc., is independent of what the demands of search are. If they were coupled together, then you would be sort of scaling your Couchbase cluster based on two different ideas, and that actually can get complicated where your CRUD operations are not in as much demand and doesn't need scaling, but you have to scale because of search. So by decoupling the two, we actually allow for independent scaling. It's very similar in terms of the process here. It's the same as XDCR. The only thing that is a little different is that once it gets to Elasticsearch, Elasticsearch also has to do the indexing of the received documents. We use it's called the Couchbase transport plugin. It's a plugin for Elasticsearch, and what that plugin does is simulate the responses that the XDCR process is expecting as in terms of HTTP responses. And by simulating it, it basically allows the reception of data. In terms of using Elasticsearch, the workflow is sort of that you do a query against, whoa, those are too fast. You do a query against Elasticsearch, you get a result set back, and in that result set, you have a set of document IDs matching your query. And then you do, sort of a multi-get off of Couchbase to retrieve the documents in that result set. So it's kind of that two-step process. It's not too dissimilar from querying secondary indexes with Couchbase, where you query your view, and if you need to retrieve the documents afterwards to display information, you do a multi-get on that result set. And in this case, it's very similar. You do your Elasticsearch query, you get a result set, and then you do multi-get against Couchbase server to retrieve the documents. So one of the first things we want to do in setting up Couchbase and Elasticsearch together is to install Elasticsearch. I do recommend, if you're using a Mac, if you've already installed Elasticsearch before, just make sure that we've got a version match, or just uninstall them all. and restart, unless you're using it for another application. But you're going to want to make sure that you match up our plugin with the correct version of Elasticsearch that you're running. I'm going to install this specific version, 90.5, which is what has been tested against with our plugin. I think the current version is actually 90.7, a couple micro versions ahead. But I'm just going to go ahead and stick with 90.5, and I'll show how to do that. So first I want to do a brew update and make sure all my formulas are current. That's just a general good practice. And then I'm going to actually install a specific version. And I actually have some notes in a gist here that I'll provide a link to at the end on the slide so that you can see kind of instructions kind of laid out here. So I'm going to do a specific version here, so brew update. So if you're on other Linux systems, you're just going to actually download the 90.5 and install it. Some of the folders in it will be maybe a little different. It'll vary in terms of where the plugin folder is, the bin folder, and things like that. But for the most part, it's relatively the same all the way around as long as you know what the folders are. So what we're going to do is brew list or brew versions Elasticsearch. Let me go ahead and grab 90.5 here. So here we've got the version for 90.5, and I'm going to go to my user local and go ahead and paste that in, and then I just do a brew install Elasticsearch. Basically, I overrode the updated formula with the from the newest version with this, and there we go. I've installed it. That's because it was already downloaded. So there we go. It's installed. Some of these folders are kind of important to remember. We're going to be using them. Here's the plugins folder we'll use, and also what it doesn't list is where it was installed. But actually, that's it right here, right? The user local seller. We're going to go there because we're going to actually set up some things there. We're going to add some information to the settings YAML file, the Elasticsearch YAML file and config, and we're going to install plugins. So let's go there and see if you do a brew info Elasticsearch. I don't think it lists the folder was installed to. Oh yeah, it does. It's up here. Okay. Anyway, so let's go to first. Let's install the plugins, and that's really easy to do. I'm going to actually copy it from here. This is for the Couchbase Elasticsearch transport. Alright, boom, it's installed. And then there's this, Elasticsearch head is kind of like a browser-based Elasticsearch interface for looking at Elasticsearch and kind of browsing around and playing with it. The plugin version, there's a standalone version and there's a plugin version. The plugin version is fine when you have just a single cluster you're looking at, and the standalone is better if you have multiple instances or clusters of Elasticsearch and you just want to use a single web interface to kind of browse them all. But I'm just going to use the plugin one. Let's install that one too. Alright, so now I need to do some config. So I'm going to go to the config folder here, and I'm going to open up the Elasticsearch YAML. And at the bottom, I'm going to add some settings. Since I am on Mac, I'm going to also have a setting in here that you would not do in Linux. This num vbuckets. On Mac, we set it to 64 because of file descriptor limits. By the default file descriptor limits in OS X, of course, I've overridden mine, and I have commands in this gist for how you override and increase the defaults. For some reason, it's pretty low. We're going to use this port. This password can be any password you want, in the user too, actually. Both these can be anything you want. I just use the same thing as my local Couchbase instance. And we have this max concurrent request 1024. So I'm going to save this settings, this elasticsearch.yaml file. Now it has that settings in there. And then I need to copy over a template. So let's look at this folder. What I'm going to do is actually, there's two ways of doing it. You can actually curl the template in with an xput, but I like this method better. I'm in the config, I'm going to make a folder called templates, and Elasticsearch will recognize this template subfolder and automatically put the template file into Elasticsearch on start, any files that are in here. So I think that this is just kind of more convenient than xputting. So if you remember, we had the plugins folder within our transport Couchbase plugin. We have like a JSON file, which is a template, like kind of a standard template. You can modify this yourself, but we include a template. So I can't remember the name of that folder, so I'm going to go ahead and brew info. It tells me where the folders are. And let's go ahead and copy transport Couchbase. So I pasted that folder in, and then I started adding more to it to get to the actual file Couchbase _template.json. I'm going to copy it here to my config/templates folder. So now I've got the this sort of default template for Couchbase documents. So, and then I think I'm good to go. I installed the plugins. I installed the template. I put in the YAML settings. Looks like I'm good to go. So I want to start it. Oops. And again, I'm just putting this information up. So I forgot how to start it. You can do it manually too, but I'm gonna do it explicitly here. All right. So I'm gonna unload in case it was already started, and reload. And I should have it running. Boom. Okay, so 9200 is the default port for Elasticsearch, so now it's running, which you can also see in your browser. All right. This one is called Bruce Banner. All right, we're in Incredible Hulk here. So if you want to see the plugin, the Elasticsearch head plugin, it's 9200/_plugin /head. And there we go, we've got an index. Now there's two ways, we've got Elasticsearch set up. So there's two ways to create a new index. You can do it through curl with an xput, or you can just do it right here. I'm going to call this XDCR to match my XDCR bucket that I've put a whole bunch of random user data in. Okay, now I have an XDCR index in Elasticsearch, but bucket index. All right, so now I'm ready to actually set it up with Couchbase. So here's my Couchbase console. I'm going to go to XDCR. I'm going to create a cluster reference. In this case, I'm going to call this Elasticsearch, and this is going to be the port is going to be from the Elasticsearch.yaml. We set up a port here 9091 that it's going to be running on. So we're going to do 127.0.0.1 port 9091, and the username and password are also from that file. An administrator, and I just use the same one as my cluster actually, because it's all local. I don't really care. So, I had a replication to my MacBook, but I think I deleted that bucket and stuff on the MacBook. That's just a regular XDCR from the other demo. So let's go ahead and delete this. I don't need that anymore. I guess I can leave the reference. No, let's leave the reference too. Okay, so here we're just looking at, so I created that cluster reference. Of course, this IP and port can be different if you use a different port in the YAML file, or if it's on another server, you put in that IP there. So now I want to create a replication on this cluster. I'm going to pick my XDCR bucket and then an ES. It says bucket, but it's an index, so index bucket. One thing that's important here is in here, I want to do the version 1 of XDCR protocol, not version 2. And in our docs we said put this to 8, so I'm going to put it to 8 because it said 2. I don't know if it'll matter on my local machine, but so I will go ahead and get that. So it's starting up, and let's go quickly over here, and let's change this refresh to refresh quickly. Oh, it's almost done. Oh no, it's half done. So it is now sending all this stuff to Elasticsearch, and it's boom, it's indexed. I can go ahead and change it to every 5 seconds. So we saw that. That was really fast, but there's about 23,000 documents just got sent here. So boom, it's indexed. So now I can try and do a kind of a query here. So here are all these random users from the Ruby Faker gem. And I guess this is sorting. Oh, look at that. How about that? Oh, this is a pretty nice browser. So I can actually sort here in the interface, or filter. Let's just try and... The name is no... Oh, maybe I can't do both at the same as trying to and them. Let's see here. I actually haven't played with this one. I was actually playing with the structured query, and then here you can actually put in like your own JSON query. If you're familiar with Elasticsearch, you know this is where you could put in your sort of custom queries and do a post. I kind of like this though. This interface is pretty cool. So it doesn't like uppercase letters, but it does do a pretty good job of filtering. So in this case, I filtered down to Ludwig S and got this user. This ID here is the document ID, but if you look at the structure here of the documents, and some of this came from the template. We've got this source document here, and then there's a doc parameter and a meta parameter for the source. This is what is getting indexed here. And it does use the underscore ID at the root of this JSON is the meta ID from the document. So it kind of copies that over. And when you do a query, you're going to be using these IDs to do multi-gets from Couchbase. Let's show a few useful links. We'll include that in the follow-up email as well. But these links are a little bit long, but what we've got here is the Elasticsearch install and configure gist that I wrote up. And then we have the Elasticsearch transport plugin GitHub repo. And there are some instructions there in the README that complement the docs. I mean, pretty much it's the same information in both places. It does talk about install on other systems a little bit. The Elasticsearch head plugin repo, if you want to install the standalone, you can look at the instructions there for doing that with it's basically using Node.js and Grunt. Then we have our Couchbase Elasticsearch documentation, which also outlines very similar information to my own gist. I just had a few things that I added for macOS in particular with Homebrew, which is not in there, so I included that as well. And we'll include these links in the follow-up email. And so that concludes our demo.
Again, I want to remind everyone, if you have more questions on Elasticsearch, on XDCR, please send us an email at webinar@couchbase.com or justdeep@couchbase.com. And again, tomorrow we will have the webinar on XDCR, which is an intro webinar, so it's not going to be too detailed. And also, if you haven't watched Couchbase 101 to Couchbase 104, there is the link on the chat box where you again, I want to thank you all for joining us today, and I hope to see you again in January when we'll restart again this training series.
All right.
Thank you, and Thank you, Justin.
Thank you for coming.